This brings us to the third of our calculus rules. So we have, let's recap. Chain rule, anarchy, bring down the power, lower the power, diff the inside. Product rule, write down the first, diff the second, plus write down the second, diff the first, which brings us to the quotient rule. What do we do when we have one function divided by another function? Here's the formal one, lovely. Here's what we actually do. Square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom. Okay? So because it's a fraction, you don't have a first and second, you have a top and bottom. So let's have a look at one. X over 1 plus 2x. Again, you do it as you say it, or you say it as you do it, whichever you prefer. Square the bottom. So that just simply means whatever the denominator is, whack some parentheses around it, squared. Done. Then write down the bottom. So now we go to the numerator, and the first thing we do is write down the bottom. So the thing you just squared, write it down. Diff the top. Well, the top is x, that is 1. Minus. So in the quotient rule, it's minus. The product rule, it's plus. Minus. Write down the top. X. Diff the bottom. 2. Tidy that numerator up, and there we have it. 1 over 1 plus 2x squared. Once again, don't worry about all this UV rubbish. Just confuses things. Try another one. You know what's going to happen here. We have 2x on the square root of x squared minus 4. So we square the bottom, but when you square a square root, they cancel. So I've just got x squared minus 4. Write down the bottom, x squared minus 4 to the power of a half. Diff the top, that becomes 2. Minus, write down the top, 2x. Diff the bottom, but when we diff the bottom, anarchy, bring down the power, lower the power, diff the inside, expel that derivative, 2x. So tidy up that numerator. But now I notice we have a common factor. Whenever we factorize, we pull out the lowest power. So on the top of the fraction, the common factor is x squared minus 4 to the minus half, which actually means that factor goes to the bottom of the fraction, or I haven't put it there yet. There's also a factor of 2, so we pull that out. Inside, we're left with x squared minus 4 minus x squared. There we go, there's our super mathematician answer. Minus 8 over x squared minus 4 root x squared minus 4. So that is our quotient rule. I'm now going to let you in on a little secret, the reciprocal rule. Okay? You will not find this in your textbooks. Your tutors will not tell you about this. So, reciprocal rule. What it's useful for is like the quotient rule, but when you have a constant on top. So you don't have to worry about the diffing the top, because the top will be 0 when you differentiate it. Differentiate a constant, you get 0. To save time, we just say this. Minus the derivative on the function squared. So if you've got 1 on x squared, yes, I could change this to index form and do it nicely, but let's use it as an example. I've got a constant on the top, so I say minus the derivative on the function squared. Well, the derivative of x squared is 2x, so I've got minus 2x on the function squared, x to the power of 4. The x's cancel, minus 2 and x cubed. Minus the derivative on the function squared. What happens if that constant's not 1? Well, just like with every other bit of calculus we've been doing, we just multiply by whatever the constant is. So in this case, when I go minus the derivative on the function squared, on the top I'm actually going to go minus 6 times 8x because of that constant being 6. So we get minus 48x on 4x squared plus 3 all squared. That's the reciprocal rule. That's our secret. Until some of you become maths teachers.